Hello children, today I brought a special device about which we are going to discuss in an entire class. Let me show you that device. Yes. So this is that special device about which today we are going to learn. Children, do you know this device? If you know this device, what I mean to say is that its name. If you know the name of this device, kindly mention in a comment box so that I'll go through and I'll check. Okay now, so in today's entire class, let me tell you, in today's entire class, we are going to discuss about this device only. Okay, fine. Children, before going to start today's session, let us recall what we had discussed in the previous class. Children, in a previous class, we discussed about least count mainly. Children, what is the least count? The smallest measurement that can be taken by any device is called least count of that instrument. For example, least count of meter scale is 1 millimeter. Least count of vernier calipers is what did children? 0.1 millimeter. That is, by using vernier calipers, we can measure that what we say length up to 2 decimals of centimeters. So today, whatever we are going to discuss about this device, it can measure the length up to 3 decimals of centimeter. Children, meter scale can measure the length up to 1 decimal of centimeter. Vernier calipers can measure the length up to 2 decimals of centimeter. This device can measure the length up to 3 decimals of centimeters. Okay children, so what I mean to say that in the last class, mainly we discussed about the least count and vernier calipers. Link will be given in the description. Kindly go to that link because that class is very important to understand today's class. Okay children, fine. Now let us see today's class agenda. Children, in today's class, mainly we are going to talk about what is the device? Screw gauge. Yes children, the first we'll try to understand what is a principle of screw gauge. Then we discuss what is a pitch. Then we discuss what is the least count. How to calculate the least count of screw gauge. Then we discuss about the main parts of the screw gauge. Then we will discuss how to determine the diameter or length by using a screw gauge. And finally, we discuss about the errors and their correction and the application related to the screw gauge. So this is what actually main topics which we are going to discuss. Children, one important point let me tell you. So generally whenever the class so-called screw gauge starts, what happens? Generally teachers will take this device, will introduce this device to a student. They'll tell this is so-called this part, they'll tell the name of each and every part and they'll just give a formula. Then they'll start calculating, they'll tell about the definition of errors and finally they'll end with the applications. But children, that is not that actually. This is not the way to learn about a screw gauge actually. First, we need to understand the principle. On which principle does a screw gauge work is very, very, very important children. That principle, see, understanding is very important. Learning is very simple. We have to understand, we have to feel that principle. We have to feel that. Then only what will happen, you can easily learn, you can easily understand, you can easily use this device so-called screw gauge to measure the diameters or lengths, whatever is given actually. Okay children, first we'll try to understand what is the principle of screw gauge. So look at here, the principle of screw gauge is simply screw in a nut, which means what children? If you know about screw, if you know about nut, and if you know how a screw is tightened or loosened in a nut, then you can understand the screw gauge. You may get surprised. Sir, what is this? Just knowing about screw and nut, can we understand screw gauge? Yes children, that is what I am trying to tell you. Again, it's very, very simple. Just try to understand about screw and a nut, then easily you can understand, you can use screw gauge in a simple manner. Hope I am clear? Yes. So let us talk about first screw and nut children. Then you can understand the principle actually. So if you can see this screw and a nut system children, look at here. So this is a screw actually. So let me show you children. So just I brought here screw and nut also. Let me just show you. Wait, let me put here. So this is screw and a nut system. Okay, fine. Children, this is a screw. Screw is what? A shaft or a metal rod on which fine threads are cut in a disciplined manner along its length. And this is called head of the screw, and this is called tip, or some people may call it as a tail also. Let us call it as a tip of the screw. And here you can see here fine threads are cut in a what a helical shape. The spiral binding knots will be there, so that is how threads are cut on the screw along its length. Okay children, fine. And let me introduce one more very important. This what actually is a nut. So you might be knowing about this. This is what actually nut. And the very important thing is that children, if you can notice inside of nut also identical threads are cut. I mean what? The threads are cut similar to this. So that what will happen? This screw can be rotated. So when you are just rotating this head, children, these terms are very, very important. So look at here, my right hand, just I am holding the head of the screw. So if I am rotating it in a clockwise direction, I am rotating in a clockwise direction. What is happening? The tip of the screw is advancing in a forward direction. So I am rotating this in a clockwise direction, so that tip of the screw is advancing in a forward direction. If I can rotate in an anti-clockwise direction, that what will happen children? The tip of the screw will come back. Hope I am clear children. That's it. Once again I am telling you, if you can concentrate on this, how we are tightening, how we are loosening this screw in a nut, then you can understand what actually the principle of screw gauge. Because again I am telling you, screw gauge is nothing but what children? It is a combination of, what? It is a combination of screw and a nut. Are you not believing? Let me show you. Let me just take out this. Of course, we'll discuss entire what a screw gauge and the parts, but before that let me show you just once again. So if I can remove this, yes children, this is a screw, this acts like a nut. That's it. That is what I am trying to tell you. So this is screw in a nut. Let me just, that's it, how we can rotate in a forward and a backward. Okay children, this is what actually screw gauge, which works on a principle of what children? Screw in a nut. First, let us try to understand the very important term related to the screw gauge. That is what children? Pitch. First, let us try to understand what actually pitch is. How to calculate the pitch is very, very important. When we are solving the numericals, sometimes pitch value may not be given, that we have to calculate. Okay children? Yes. To understand the pitch, once again let us come back. Children, as I told you that understanding this is very, very important. If you can understand this, I mean just feel it. As here I am tightening and loosening, just you feel as if you are tightening and loosening, then what will happen? You will be involved and you can understand, you can feel the concept, you can feel the principle of screw in a nut, then you can understand it very easily. Okay, fine children. So now what is happening children? Here the head of the screw is rotated. You can rotate in anti-clockwise or clockwise. Let us suppose the head of the screw is rotated in a clockwise direction. As the head of the screw is rotated in a clockwise direction, don't you think that children, the screw is traveling forward? Yes, screw is traveling. I mean what? As you are rotating the head of the screw, what is happening here? The screw is traveling, it is covering some distance along its axis. Children, again I am telling you, as we are rotating the head of the screw in a clockwise direction, what is happening? The screw is covering some distance along its length. The distance only we are going to call it as a pitch. Repeat once again, it's very, very important. Very, very. What is the pitch? Try to understand the concept. Feel the concept. Whenever we rotate the head of the screw, what happens? What happens children? This screw can cover some distance. That distance only we are going to call it as the special name called pitch. But exactly how? That is what actually I told you is just idea. But exactly, you make it a one doubt. Sir, for example, I will rotate 10 times, it covers some distance. My friend will rotate 5 times, it will cover some distance. One more friend will rotate 20 times, it covers some other distance. So these distances are different for different people. Then how can we say about it? Children, for that I am telling you in a unique manner what we have to children. For example, here I am holding this. For example, just try to make one complete rotation. either it is you or your friend or some other friend, what it may be. So for a given, again tell you, for a given screw and nut, anyone, for example, if I can make one complete rotation like this, again I repeat once again, I am making one complete rotation. For this complete rotation, what will happen, children? The screw will cover some distance along its length. That distance is called pitch of the screw. I repeat once again, the distance covered by the screw along its length for one complete rotation of its head, is called what actually? Pitch. Now let us see mathematically how to calculate the pitch, children. So pitch is equal to, it's very important, distance covered by the screw, by number of rotations. Very simple, number of rotations, that is P is equal to X by N. Children, it's very important. How to calculate the pitch, children? What we can say, the distance covered by the screw by a number of rotations. How many number of rotations you are making and what is the distance covered by it, by the screw actually. So with the help of this, we can calculate the pitch. Children, what is the pitch definition, children? The distance traveled by the screw along its length for one complete rotation of its head. Is called pitch. But mathematically, children, let us see for example. So if you can see, children, two threads, if you can see, let me make a bit like in a zoom mode. Let us try to see here. For example, let us say it's a screw. Over it, let us say it's a one thread. Let us say one more thread. Children, this much big won't be there. Just in a zoom mode, I'm trying to tell you. Okay, fine. So what I mean to say is that this is what actually screw. Let us say. Oh my God, let me tell you. Let me draw the screw. Okay. So this is, let us say, is a head of the screw. So for example, it is a point A. Once you're turning here, again this point A should go up. For one complete rotation, again I'm telling you, children, look at here. For example, here I'm holding like this. Okay, na? So complete rotation. When you can make one complete rotation, children, you know what happens? The screw can cover a distance which is equal to the distance between the two successive threads. Very important. Again, I'm telling you, if you can make one complete rotation, the screw can cover a distance which is equal to the distance between these two, I can say the two successive threads actually. Okay, children, usually the distance between these two successive threads will be 1 millimeter. 1 millimeter. Try to understand. 1 millimeter. So if you can make a one rotation, then what will happen, children? Distance pitch, the screw can cover 1 millimeter distance. If you can make a two rotations, 2 millimeters. If you can make a n rotations, then it can cover n into 1 millimeter. Okay, na? So according to this, children, actually, let us suppose we are making one complete rotation, that is n is equal to 1. Then what is the distance traveled? 1 millimeter. Now let us calculate. Pitch is equal to 1 mm by 1. So pitch is 1 millimeter. Pitch is 1 millimeter. Children, usually whatever the screw gauges which we are using in a laboratory, usually they will have the pitch which is equal to the 1 millimeter. For suppose, children, some kind of screw gauges will be there where you have to make a two rotations, so that what will happen? They will travel a distance of 1 millimeter. Yes, of course, it is possible. We can make. Means what I mean to say that, for example, if you are making a two complete rotations, so that what will happen? The distance covered will be 1 millimeter. Then what is the pitch? How to calculate the pitch, children? Pitch is equal to distance traveled is how much? 1 millimeter by number of complete rotations. Number of complete rotations is how much here? 2. So pitch is equal to 0.5 millimeter, 0.5 millimeter. So pitch depends on here two factors, the distance covered by the screw and number of complete rotations made. Is that clear, children? Yes. So this is what actually pitch is. Again, I am telling you, children. Again, you may get one doubt, sir. You said that we are going to discuss about screw gauge, but we are talking about just a screw in a nut. That's what I am telling you, children. So again, I am telling you. Look at here. This is a screw. This is a screw. The distance between two fine threads. The distance between two fine or successive threads will be 1 millimeter. Will be 1 millimeter only. So it serves like this. This is a screw. Try to understand. Very important. Or else, yeah, let me tell you. This is a screw. Okay, na. This is a nut. So screw in a nut. This is how actually. Let me just. Yes. So this is. Here we are rotating the head, right, children? So this is how actually we are rotating. As we are rotating, now look at here. The screw is coming. The screw is advancing in a forward direction. Means for every rotation, for every one complete rotation, screw will cover some distance. Screw will cover distance. That only we can call it a pitch. Usually, in general, as a distance between two fine threads will be 1 millimeter. So if you can make a one complete rotation of this, then what happens? The screw will cover a distance which is equal to the distance between two fine threads, that is 1 millimeter. So that this is how actually we can calculate the pitch of the screw. So again I am telling you, this is what actually pitch of the screw. Now we discuss. Now we discuss what actually the parts, what are the main parts of the screw gauge, and after that we will see what is the least count of a given screw gauge, I mean how to calculate, then what is the errors and the related. Just you copy this, children, then just we go for the screw gauge description. Yes, children, look at here. Children, if you can see, screw gauge is consisting of U-shaped metallic frame. Look at here. U-shaped metal. Children, again I am telling you, if we take a little bit more time also, no problem. Let us understand each and everything. Let us feel the concept of screw gauge. Okay, children, just be with us. We'll make you to feel the concept of screw gauge. Okay, children. So this is what actually U-shaped metallic frame. So for this, children, again I am telling you, for this, so left side if you can see, a small metallic shaft is fixed. This we can call it as a stud. Some special names will be given. It is fixed one, children. The shaft is fixed. A small shaft is fixed. Left side of the U-shaped frame, it is called as stud. You can see here. So the small one will be there. You can hear. The small thing is fixed. The small thing, I think, hope you are able to see. Just here, you can look at here. This is a small shaft is fixed. This only we can call it as a stud actually. And the right side of this, children, if you can see, a sleeve hollow cylinder is fixed. Again I am telling you, a hollow cylinder, it is also called a sleeve cylinder. It's very important. So try to understand the terms. This is actually hollow. This one we can call a sleeve cylinder. Children, we can say sleeveless shirt. It's a sleeve, right? So that inside nut can be fixed. Children, this hollow or sleeve cylinder only is going to serve as a nut. Try to understand. So let me just show you. Just children, have patience. So children, now this is what actually just I made. Okay, na? It's a U-shaped metallic frame. Right side, okay, na? A cylindrical. Again I'm telling you, a cylinder is fixed. A hollow cylinder is fixed. This one we can call it as a sleeve cylinder also. So this is going to serve as a nut like this. So try to understand. So like this nut, it is going to serve as a nut. Again I am telling you. Okay, children. So inside, if you can see, inside of this cylinder, threads are cut identical to the threads which are made on the screw. I mean, where is that screw? Yeah, like this. On this screw, how the threads are made. So identical to these threads, similar threads are made inside in a helical shape. In a helical format, they are made. Fine. And children, on this, I mean say on the surface, on the outer side of this sleeve cylinder, a scale is calibrated. A scale is calibrated so that this going to serve as a scale. This is going to serve as a scale. Let us see here how it is made. So this is how one scale is made, children. 19, 20. Okay, let us say. Means the distance, if you can see, again I am telling you children, it's very important. The distance between each division is equal to the 1 millimeter. I mean, if you can see, this is, children, this line, whatever is made on the surface of the sleeve cylinder is, we are going to call it as a baseline. Children, it's very important. This only we are going to call it as a baseline. This is a baseline, and this, if you can see, divisions are made. So the distance between each division is equal to the 1 millimeter. Now you can recall the concept of pitch, children. So when I was discussing about the pitch of the screw, there very clearly I said that the distance between two, what we can say, the successive threads is equal to the 1 millimeter. So as you can make one complete rotation, the screw can cover the distance which is equal to the distance between these two divisions. Okay, children. So here one scale is calibrated on the surface of the sleeve cylinder. So this scale only we are going to call it as a pitch scale or main scale. Pitch scale or main scale. So hope I am clear. Again I am telling you. So on the surface of the sleeve cylinder, a scale is calibrated which is going to serve as a pitch scale or main scale. Now children, if you can see here, so this what till now which we discussed. Now here is what, children, if you can see here, here is one more long shaft on which what we can say fine threads are made, so that it is going to serve as a screw, as I told you. On this screw, children, if you can see, one more hollow cylinder is placed. This one we can call it thimble. This one we can call it as a thimble. And at the end of the thimble, children, this is called actually a ratchet. I'll tell you the use of the ratchet at the end of this description. Okay, children, fine. Now, if you can see here, this, as I told you, that is going to serve as a screw, and if you can place in it, and if you can rotate in a proper way, so then what will be, just let me just adjust. Yeah, as you are rotating this, if you can see thimble, as you are rotating this thimble, what is happening, children? This shaft, I mean this screw is advancing in a forward direction, So let us complete the diagram now. So hope this pitch and main scale is clear, children. Again I am telling you, a scale is calibrated on the surface of the, what we can say, hollow or sleeve cylinder, which is attached to the right side of the U-shaped metallic frame. Is it clear? Fine, children. Now let us take out this, let us complete this diagram. Fine, children. So as I told you that inside, so this scale again we will make afterwards. Okay, the disturbance tower diagram. Fine. So inside what will be there, children? If you can see, this is what actually screw. So here is what actually screw. If you can see, here is a screw. Yeah, let us draw it properly. This is screw actually. Yes, here is a screw. Okay, children. So on which final, again fine threads are made identical to the nut actually. Identical to the nut. So on this, children, as I told you that what will happen, so there will be one more hollow cylinder will be there. Hollow cylinder will be there. This is what actually hollow. Wait, let me make properly. Hollow cylinder. Yes, this one we can call it the thimble. Okay, na? So at the end of this, one ratchet, this will be there. Let me just, yeah. So this is how it is made. Just let us make similar to this. Okay, then here is finally, this is a ratchet. This will be ratchet. This we can call it as a thimble. This we can call it thimble, and this is U-shape metallic frame. U-shape metallic frame. It is a stud. It is going to act like a screw. Children, this is how actually means we are scanning, children. Inside actually, if you can see, you can't see. You can't see the internal part, just we are scanning, again I'm telling you. So inside how they are arranged. But outside if you can see simply, so these things, internal parts won't be seen. Actually, this is how actually it is made. Okay children, now we are going to adjust this diagram so that it looks like how it is looking like this. Okay na? Fine. So let me take out this, because this part you can't see because it is inside, it is completely arranged. Try to understand. This you can't see completely. You only can see this thing. Now I am going to draw how actually we can see a screw gauge from outside. Okay na? So this will be there like this. Yeah, this is how it will be there. So this is, as I told you, that it's a baseline. So this is called baseline on which divisions are made so that it serves as a scale. This scale only we are going to call it as a pitch scale or main scale. But here the question is that children, as we are rotating it, the screw is advancing in a forward direction. Okay, no problem. But the question is that what is the least measurement that we can take, with the help of screw gauge is very important. Children, this point is very important. Even I went through a few textbooks where it is not mentioned clearly, directly formula is given, just they said what is what and they calculated the least count. But children, try to understand. See, what is our intention? Our intention is to measure what is the least measurement that we can take with the help of screw gauge. Means here you make it a one doubt. Sir, okay sir, if I can make one complete rotation, yes, it will measure 1 millimeter. It's clear. Means, for example, let me tighten this. Children, first in the beginning, let me tell you one thing. We are discussing about the device where there is no zero error. We'll discuss about the errors in the last, what we can say, at the end of this session. Okay, fine. So initially, let us suppose just try to, yes, rotate it so that children, this screw should come in contact with this stud. And after that, once you make this ratchet, once if you can just try to just rotate it so that you can hear a kind of some tick tick like that you can hear. Okay, hope I am clear. Fine. Now the thing is that when I can make one complete rotation, okay, there will be a gap. If you can see, I don't know whether you are able to see it or not. There will be some gap. There will, which means what? That is a distance. That is a distance. Of course, that we can measure. But what is the smallest division, what is the smallest measurement that we can take with the help of screw gauge, children? It's not one complete rotation and you make it one doubt. Sir, for example, you made one complete rotation like this. Okay, no problem. It just covered some distance that we know that is 1 millimeter. For suppose your friend has rotated but not completed one rotation like this only. Little bit I made. Children, little bit I made, so that for this little bit rotation also what happens, screw can cover some distance, then how to calculate that least measurement, children? So for that we need to have one more scale, very important. If you want to measure that least distance with the help of screw gauge, we are going to have one more scale. Where that scale is made? That scale is made on this halo cylinder. If you can see here, children, whatever is being rotated, this is what actually halo cylinder, and that the scale is made. That only we can call it as a head scale or circular scale. So on this only, children, on this only, if you can see, let us say it's a 0, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 95. Then you can understand how many divisions are made over this, children. 100 divisions. You can't see 100. Look at here. It is 95, right? 96, 97, 98, 99. It's 101. Means how many divisions are made? 100 divisions are made. Where? On this thimble, children, at here. So that it going to serve as a scale. This scale only we can call it as a, we can not main scale, sorry, we can call it as a head scale. We can call it as a head scale or circular scale. Circular scale, children. Again, I'm telling you, the least count of the screw gauge depends on the divisions made on the circular scale. So very important, very important. Children, once again I'm telling you how to calculate the least measurement. For suppose, children, For one complete rotation, for example, let us say it is a 0. Let us say it's a 0. For children, top is 0. Let us suppose top is 0. If I can make like this, again I am bringing 0 to top only. Which means what here? I made one complete rotation. Means how many divisions are made here for one complete rotation? 100 divisions. Try to understand, children. For one complete rotation, we know that screw can cover the distance which is equal to 1 millimeter. Okay, now fine. It is a 1 millimeter. It's a 1 millimeter. Is it clear? Fine. But I want to measure the least distance taken. Least distance measured. Children, one complete rotation. For one complete rotation, how many divisions are covered on a circular scale? 100 divisions. One complete rotation is made, means what here? 100 divisions are covered. Which means what? One complete rotation equal to 100 divisions on circular scale. 100 divisions. If you can make 100 divisions for one complete rotation, screw can cover 1 millimeter. Screw can cover 1 millimeter. For one division, children, then what is the distance covered? For a one division, which is equal to the 1 by 100 millimeter, which means what? 0.01 millimeter. So this is the least measurement that we can take with the help of screw gauge. Children, did you understand or not? Yes, let us feel it. Again, I'm telling you. So one division means what, children? Here, children, on these 100 divisions are made, right? 100 divisions are made. If you can make you are rotating it so that only one division is covered. I mean what here? Before it is at 80, let us say 80 to 81, which means one division is covered. For that one division of rotation, the screw can cover some distance which is equal to the 0.01 millimeter. So this is the smallest measurement that we can take with the help of screw gauge. That is what, children? 2 decimals of millimeter, or it is also we can add 0.001 centimeter. This is what actually least count of screw gauge. Which means what, children, here? Least count of screw gauge depends on here 2 factors. What is that? For one complete rotation, this is 1 millimeter. This is nothing but what, children? It's pitch. Nothing but what actually it's pitch. And here what? Number of divisions made, children. Again, I'm telling you. Number of divisions made on circular scale. Number of divisions made on circular scale. So as per this given screw gauge, children, here the pitch is 1 millimeter for this screw gauge, and the number of divisions are made are how many, children? 100. Which means what? If you can divide the pitch of the screw gauge with the number of divisions made on circular scale, you will get the least count. So now let us write the formula of the least count, children. So let us write the formula of this one. So children, hope it is copied. Just copy it. Now let us understand the least count. Least count. So how are we calculating the least count, children? It is pitch by number of circular scale divisions. Number of circular scale divisions. This is a pitch P, number of circular scale divisions are N. So we can write here least count is equal to pitch by number of circular scale divisions. Number of circular scale. So how to calculate the pitch? Already we discussed. Pitch is equal to distance traveled with the screw by number of rotations, number of complete rotations made. Number of complete rotations are made. Okay, children. Now look at this. Again, I'm telling you, it's very, very important here. Least count depends on 2 factors. One is pitch, the other one is number of circular divisions. Okay, now, so least count is proportional to the pitch, and the least count is inversely proportional to the number of head scale, number of circular scale divisions. In exam, they'll ask you a question. How can we decrease the least count? Children, in a previous video we discussed, if you are decreasing the least count, which means what? You are increasing the accuracy. Always we try to make a device so as to have a least value of least count. So try to understand. So we have to decrease the least count so that accuracy will be increased. So here in exam, they may ask a question. How can we decrease the least count? How can we decrease the least count? So it's very, very important. So least count can be decreased, least count can be decreased, least count can be decreased by increasing the, sorry, by decreasing the pitch, by decreasing the pitch, by decreasing the pitch. I mean, what how to decrease the pitch, children? The distance between two successive the threads will be there, you know, that distance should be decreased. Then automatically what will happen? The least count will be decreased. And the second one, children, by increasing the number of circular scale divisions. By number of circular scale divisions also we can decrease the least count. Just let us take one example, children, so that you will understand very easily. Look at here, children. Let us take one example, children. One example, let us say it is a screw gauge 1 and here is screw gauge 2. For both, children, let us say the pitch is common. Let us say that is a 1 millimeter only. The pitch of the two screw gauge is a 1 millimeter only. Okay, fine. But the difference is that in a screw gauge 1, the number of circular scale divisions are 100. Okay, whereas the screw gauge 2, the number of circular scale divisions are 200. Now my question is that which screw gauge will have more accuracy? Children, it's very, very important. Which screw gauge will have more accuracy? Just pause the video, have practice, I mean just calculate and mention a comment box whether it is the first screw gauge or second screw gauge. Okay, children, come on, children, do it. When you can do it only, what will happen? You will get the command and the content. Okay, children, come on. 3, 2, 1. Look at here. So, children, we know that least count is equal to pitch by number of circular scale divisions. It is 1 millimeter by it is 100. That is least count is equal to 0.01 millimeter. That is fine. But here least count is equal to 1 millimeter by it is 200. So here least count is equal to 0.005 millimeter. Children, try to understand. Yes or no? This is 0.01 millimeter only, but this is 0.005 millimeter. Means this screw gauge has less least count, which means what? More accuracy. Children, last class we discussed least count, that is the accuracy is inversely proportional to the least count. So here what I am trying to say is that's very, very important. So how to decrease the least count? So here least count is decreased. What way? Here more number of circular scale divisions. Is that clear? So here the least count of screw gauge can be decreased by decreasing the pitch or by increasing the number of circular scale divisions. Okay, children. So this is how actually we can calculate the pitch of the screw gauge, and we also can calculate the least count of the screw gauge. Now, children, let us see how to determine the diameter of a given wire. I mean what? First, once again, let us try to see what is the application, children. Mainly actually with the help of screw gauge, we can find the diameter of a what we can say very, very small solid spheres, and we also can measure the radius of a thin wire, and we also can measure the what we can say thickness of a a thin glass plate like a paper type. Okay, na? So these are the applications. But how can we determine? Let us see now. Children, now we'll see the diameter of a thin wire. Children, once again I'm telling you. So we are assuming that there is no zero error, and we are doing. So at the end we will see if zero error is there, how to calculate the diameter or thickness. Okay, children, fine. Now, children, so again I'm telling you. So let us assume that there is no zero error in it. Okay, fine. So what we have to do? Just look at here, children. And just let us rotate this thimble so that the screw will be going backward. Then, children, make sure that, for example, let us take this is a thin wire. It's not a thin wire, it's a marker only. Of course, even children, why can't we calculate the diameter of this marker? Yes, we can calculate. Fine. So it should be placed in between shaft and what we can say this screw, and let us rotate in a clockwise direction so as to hold the marker. Yeah, fine. Acha, sometimes students will get out, sir, on this U frame shape something is written 25 into 1 millimeter. Children, the 25 which means what actually? The 25 divisions. Look at here, 25 divisions on this pitch scale. This 25 here, if 20 is there, the length will be 20 mm. If 15 is there, the length will be 15 mm. So that's very important to understand. Okay, fine. Now, once it is held properly, make sure that this is muted so that you can, here we can one tick sound you can hear. So this is how now we arranged. Now thing is that we need to calculate diameter. First let us write the diameter formula, children. So here diameter formula is equal to main scale reading, that is pitch scale reading also you can call it as it, okay now, plus circular scale reading. Very simple, circular scale reading. But how to calculate this circular scale reading, children? It's very important, very important. So here this circular scale reading is equal to what we can say, least count into number of divisions, number of coinciding divisions. I'll tell you that how to take that n value also, I'll tell you in a simple manner. It's very simple. Now children, the thing is that here first, for this, in this case actually, what is a main scale reading? So children, let me tell you here. So this is a head scale, so 10, 11, 14. So I can see this is a 10th division, and a 1, 2, 3, 4th one I can see. Okay, now the 5th one I can't see because this circular scale is there. Circular scale is there. Circular scale is there. So which means what you can see here, 10, 11, 12, 13, 14. This is going to be a main scale reading. So here main scale reading is going to be a 14 millimeter. But children, so least count already we calculated. Here the number of circular scale divisions are 100 and the pitch is 1 millimeter. So that least count already we know that is how much? 0.01 millimeter. 0.01 millimeter. But how to take this n value? It's very important. Children, look at here. Let me tell you here. The 4th one. Let me tell you very clearly. So this is what actually this one. Pitch scale. This is circular scale, children. Circular scale. Here some divisions will be there. Here some divisions will be there. So if you can see, children, on the circular scale divisions or these divisions will be there. Only one division, one particular division will coincide with the baseline. For example, in this 72. So for example here, this is number 70, 71. This 72 is coinciding. So try to understand. So whatever the number of division on circular scale which is coinciding with the baseline will be the n value. Okay children. So as per this, here n is equal to 72. Now you substitute in this, d is equal to 14 plus 0.01 into 72, which is equal to 14 plus, so 0.72. This is going to be 14.72 millimeter. So this is what actually the diameter, children, the diameter of this marker. If you want to calculate the radius, children, how to calculate the radius of this marker? Radius is equal to diameter by 2, so that you also can calculate. It is a 14.72 is a millimeter. If you want in a centimeter, this will be 1.472 centimeters. So this is how actually we can take a main scale reading and we can take the value of circular scale reading. Again, I'm telling you, circular scale reading, how to calculate, children? Here least count into the number of division on a circular scale which is coinciding with the baseline. Some textbooks it also given index line also. Actually either it is index line or a baseline. So meaning is the same only. Okay na? Again I repeat once again. How to take the n value, children? The number of division on the circular scale which can coincide with the baseline is going to be n value. Is it clear? Just copy it. Now we discuss the errors. For suppose if error is there, when you can say that there is no zero error. If error is there, what is the, when you can say it's a positive error, when you can say it's a zero negative or negative zero error, and what is the, how the correction is done. Okay children, just copy it. So 95. So children, now let us see how to just check whether zero error is there or not. If the some zero error is there, then how to identify whether it is given one, whether it has a positive zero error or negative zero error. Children, to check whether a given screw gauge has zero error or not, what we have to do? Just try to rotate in a clockwise direction this thimble, so that the screw is advancing in a forward direction. So as you go on doing it, after some time what will happen? Both will come in a contact. Both will come in a contact, children. After means once both will come in a contact, this what we can say ratchet is there, just try to rotate once, so that you can hear a tip, a bulky one sound you can hear. Okay, fine. So now here what happened, children? Here now this stud and a screw both are in contact. Once they both brought in a contact, such a way that if the zero reading on circular scale, children, on circular scale, if it is coinciding with the baseline or index, if it is coinciding, then it is said to be has no zero error, so that directly you can use it. Directly you can use it. Children, once again I am telling you, if the zero reading on circular scale is coinciding with the baseline, it has no zero error. If it is not coinciding, then it is said to be has some error. Children, if it is not coinciding, what may happen? Either this zero may be lying below the baseline or above the baseline. Based on that, we will have two types of zero errors: positive zero error, negative zero error. Now look at here, children. For suppose these both are brought in a contact such a way that zero of the circular scale is lying below the index line, then it is said to be has positive zero error. If the zero of the circular scale is lying above the index line or above the baseline, then it is said to has a negative zero error. But how to correct this actually? How to correct it? How to correct? It's very, very important. Children, it's very, very, very important. Children, positive zero error value will be always positive. Negative zero error value will be always negative. I think you may have some confusion. Let me tell you. But how to just get the corrected value? Children, corrected value, corrected reading. Children, corrected reading, reading is equal to measured value, measured reading. Let us say measured reading minus zero error. Always minus, you do the always minus zero error only. Minus zero error, let us say. For suppose, children, in just a previous, we have done one numerical where we got some 14.72 millimeter, let us say. Example. I didn't remember how much value which we got. So let us say the measured value, measured reading which we got 14.72 millimeter, let's suppose. In that case, children, in that case, for suppose the positive zero error, for example, that particular screw gauge has a positive zero error, its value will be, for example, 0.015 millimeter is given, for suppose. Okay, as I said that it is positive always, it is always positive. Okay, then how to take the corrected reading here? Children, corrected reading is equal to measured reading is how much? 14.72 minus zero error is how much? Plus 0.015. So this is going to be a 14.72 minus 0.015. Okay. So what is the value which you will get? That is going to be a actually corrected reading. When we can have this, when it is a positive error. For suppose it is a negative zero error, let us say. So negative zero error for that particular screw gauge, it was calculated the negative zero error. Children, not to worry. You may get one doubt, sir, how to calculate all these zero errors. So as I said that next we are going to make a video where we are discussing a numericals that very clearly will tell. In general, children, up to as it is the 9th class standard, definitely the value will be given. The zero error value will be given. If not, if it is not given, the zero error value is not given, how to calculate? Yes, that we will discuss in detail in a next video where we will be discussing the numericals. Okay, yes. So for suppose, children, the negative zero error value is given. Try to understand. For example, 0. Same thing. Let us 0.0 some 10 millimeter. Let us say 10 millimeter. Then what is the corrected reading, children? Corrected reading is equal to measured reading. For example, for suppose the measured reading is 14.72 only, minus of minus 0.010. So this is going to be a 14.72 plus 0.01. So you will get some value. Means what, children? If it is a positive zero error, that value must be subtracted. If it is a negative zero error, that value must be added. You may get a one doubt, sir, why we should add, why we should subtract if it is a positive error? Which means what, children? Already before rotating it only, it has covered some distance. Okay na? Before rotating it only, before going to keep object only, it has some value. So when you can just do experiment, what will happen? You will get obviously extra value. That extra value must be subtracted. Okay na? Whereas here what, in a negative value? In a negative value, what will happen? What is the zero error you will get? What is zero error that value has? That must be added so that that value will be compensated. Okay, children. So this what actually no zero error case, positive zero error case, and here is a negative zero error case. Okay, children. So this what actually today's class. Children, once again I'm telling you, instead of understanding about directly about the screw gauge, first try to think about the screw and a nut. Why? Because screw gauge is nothing but the combination of screw and nut only. So children, let us recall once again what we had discussed today's class. So first, children, which we discussed about the least, what we can say, pitch. Children, what is the principle of screw gauge, children? Screw in a nut. What is the pitch, children? The distance covered by the screw for one complete rotation of head. It's a one complete rotation is called pitch. Then what about least count formula, children? Of course, how to calculate pitch, children? Pitch can be calculated. How? What we can say, distance traveled with a screw by number of complete rotations. Then how to calculate the least count? Least count can be calculated pitch of the screw by number of circular scale divisions. Children, you know, most of the students will have a confusion between the definitions of pitch and least count. Children, again I'm telling you, I will try to show you definition on screen also. Both seems to be same but not same, just small difference will be there. What is that? Pitch is what? Distance covered by the screw only for one complete rotation. Okay, na, fine. But what about least count? Least count also distance traveled by the screw only, but one division of what? Circular scale, one division rotation only one division we have to rotate. For that, what are the distance it has covered will be the least count. Okay, children, fine. So here we have three types of errors, children. If the zero means when what we can say, screw and stud both are brought in a contact, if the zero of the circular scale is coincident with the baseline, it is said to be has no zero error. If the zero of the circular scale is lying below the baseline, it is said to be has positive zero error, correction is negative. If the zero reading of the circular scale is lying above the baseline, it is said to be has negative zero error and the correction is positive. Okay, children, this is all about screw gauge. Okay, children, fine. So in the next class, we will be discussing the numericals based on vernier calipers and screw gauge. That is, I think, exercise 1B numericals. Okay, children, thank you so much. All the very best.